Alright, so this is a sheet that we used yesterday in our mineral identification lab. For those of you who weren't here, this is a great tutorial for you to see exactly how we did it. And for those of you who were here, it's good for us to go back through and kind of review exactly what we did. Now we'll take a look at one of these minerals, this first one. It says number 10 on it, but in the box for your lab, it's labeled number 1. So we know that this is sample number 1. Now to begin with, we want to find the streak, or the color of the mineral in its powder form, and we use the streak plate. Now if I take this mineral and I push it firmly against it, right here I can see a white streak that results. Now I'll even run my finger across it and show it to you. So I would put up here for streak the color of the powder that's left, which is white. Now what is the color of the mineral when I look at it? You may say green, or kind of greenish, grayish, a little yellowish. I would say that this is very green. So the color on here I would label green. Now the hardness. Looking at the bottom, this is our Mohs hardness scale. We have the hardness 1 being the softest, all the way up to 10, which is the hardest, a diamond. Obviously, we're not going to have a diamond in this class. We're not going to be doing any tests with a diamond because they're very expensive and you would all try to run off with them. But we are going to have potentially any of these other ones, but we can use these also as a reference for what the hardness of our mineral is, to identify the mineral. On the right side, we have a list of objects that will be provided for each lab kit, and we can use these to test the hardness. So to begin with, we'll go from the softest, the fingernail. Does a fingernail scratch this? The answer is yes, it does. I can see that it scratched the surface. Therefore, if a fingernail is harder than this mineral, then it must be, because the fingernail is at 2.2, it better be a 2 or less. So I don't know if it's a 2 or a 1 for the hardness. I'll just write a 1 to 2. Cleavage and fracture. I know this will stump a few of you. Let me show you another sample real quick to show you a good example of cleavage. This is a very, very good example of cleavage. The surface is flat. It's very shiny, and when I say that it's shiny, I don't mean like this mineral where I see a few specks of shininess in it. I mean this, the whole surface will reflect light simultaneously. So it's smooth, flat, and shiny. Those three things, that means that this is a cleavage plane. Now this side is as well. However, since they're in the same direction, it's considered one cleavage plane. Now this one, we don't see anything that looks like a cleavage plane on it. However, we don't have the best samples in this class either, and so this one actually will have one cleavage plane to it. In class, I'll be walking around, I'll be helping everyone just to make sure that you have some grasp on that, to make sure that you're not going in the complete wrong direction with the mineral identification. Now the luster. All you have to ask yourself is, does it look like a metal or does it not look like a metal? Does this look like a metal? No. So I'm going to put non-metallic. It does not look like a metal. The clarity. Can I see any light passing through it? If I hold it up to the light, probably no. At some portions around the edge, I may see some light passing through it. A good example of light passing through, let's go back to this one. You can see lines actually going through the mineral. And a good example of one that has no light whatsoever, opaque, is this one. So for this sample, if you put opaque or maybe slightly translucent, meaning just a little bit of light, I would take either or for that. So I will go ahead and put opaque. Other properties to it. Does it smell funny? Does it do anything to a magnet if I place a magnet next to it? One thing about this is that it has a funny feel to it. When you feel it, some people may call it greasy, but most people would say that it feels kind of like soap. So I would say a soapy feel. That may or may not help us in identifying this mineral. Now I'm going to go to my mineral sheet, and this is going to help me identify what the mineral is. So first off, at the top we see non-metallic minerals. This one is non-metallic, so it may be on this paper. There's going to be 4 sides total, 4 papers, so we got to make sure we're on the correct paper. Hardness 9:1. The hardness is 1:2, so that fits in there. However, it says fracture over here, and I told you there's no fracture, it's cleavage. And so we're going to go to the next page. Non-metallic, that's good. Hardness 1:4, good. And cleavage off to the side. Okay, great. We'll go ahead and stick with this paper. Now, this is nice because it has a hardness listed from the bottom up, going from smallest to largest. And so we said it's 1 up to probably less than 2.5, so we're going to check down here at the bottom. Streak, white and white for both of those. Well, we said white was our streak color, so that's possible. Hardness, 1.5 to 2 or 1. Those are both possible. Fracture or cleavage. This says perfect in one direction, 2 indistinct. One direction, but usually indistinct. Both of those sound possible. However, I told you that there's only one cleavage surface. The luster, pearly to greasy. Again, we said greasy or soapy was a good word to describe the feel of this. The diaphaneity, that just means clarity. Can you see light passing through it or not? And this has translucent or opaque, whereas this one is only transparent and translucent. Feels greasy, tiny flakes upon rubbing. Talc. That is my mineral. That is number 1, and that is all that we do for the rest of these minerals. If you don't know what the mineral is and I tell you that you're wrong, start back over. Make sure you have all of these properties correct and go back through your list. Also, double check to make sure that at the top of your list, these are correct. If you have something that is looking very metallic, you don't want to be on this page. You want to go to the metallic minerals. Okay?